Today we'll tell you how you can successfully set up an R project so that you can easily work on it, you can easily enhance it, you can easily maintain it, and you can easily share it with your colleagues, who will then be able to start to work on it immediately. Now consider this: have you ever received a piece of R code that you don't really understand, you don't even know where to start from? Maybe that code is even yours. You just worked on it maybe a week ago, or a month ago, or a year ago, but right now you cannot remember why you did things in a certain way and how that code works. Now, this is a common thing, it happens all the time, and it's something that will significantly slow you down, and it will also slow down the development team and the operation team when they try to take a proof of concept and put it into production. Good news is there is an easy fix, and today we'll show you my approach. It is a solution that I've recommended to all my clients and colleagues for quite some time now. And it is also a very flexible solution. It's something you can use for exploratory code or for our package, for our Shiny app, or for a Plumber API. And today we'll keep it simple, but I will assume that you already know a few concepts. I assume that you already know how to use RStudio, the renv package, the testthat package, or the config package. Now, if you don't know those things, no worries. I will leave a link in the description below to the relevant documentation, but I'm also working on some videos to explore those tools in more details. Okay, let's get started. But even before we go into coding, there are three main things we need to discuss. We need to discuss how we want to write our code, what we want to use to write it, and where we want to save it. Now, about how we want to write our code, that's what we refer to as coding conventions. Things about stuff like how to name your functions, how to name your variables, your files, even how to structure your project. If your team has a set of rules, you should follow those. Consistency here is the most important thing. If your team doesn't have a coding convention, then please start to work on some. A good place to start are the Google and the Tidyverse guidelines, and I will leave a link in the description below. About what to use to write our code. If you use R, there's no discussion here. You should be using RStudio. The only thing to discuss is if you should be using RStudio Desktop or RStudio Server. Now, your organization will dictate your preference. Just use what they suggest. Normally, RStudio Server is preferred to RStudio Desktop. That's because it's better supported by your IT department, and it also resembles to the production environment more closely than RStudio Desktop. So probably, if you have the choice, just prefer RStudio Server to RStudio Desktop. And finally, where to save your code? Again, there should be no discussion here. You should use some sort of version control system. If you use RStudio, then Git and Subversions are perfectly supported, so you can use either, but you should use one of the two. Okay, we're now ready to start coding. As we discussed earlier, we want to use a version control system, and I'm using GitHub for this project. I've already created my repository, so we're now ready to start cloning it into RStudio. When you work in RStudio, you don't want to use a simple folder to store all your work, but you want to use an RStudio project instead. An RStudio project will look a lot like a folder, but it's more powerful than that. You will be able to keep all your files and data and scripts into a folder, but you will also be able to create specific settings and rules that are relevant to just the project you're working on and not any other project. So to create a project, we first need to click on this icon on the top left. We don't need to save anything right now. And we are using version control, so we want the last option. I'm using Git, so I will use this option. All you need to do now is to paste the URL of your repository here, give it the project a name, and then click Create Project. Now, I've already done this step, so I'm going to cancel. But after you've done that, you will end up with a new folder with the name of your repository. And inside the folder, you will find everything that was in the repository. Because I created the repository in GitHub, I already have a couple of files that are very useful. Obviously the gitignore, but also the README file. And we're going to look at those in a second. The file rproj is something that RStudio creates automatically every time you initiate a project. And again, we will look at that later. The first thing I like to do is to activate my virtual environment. So that's simply a matter of calling renv activate. Now we have a renv folder, which is where all our library is going to be installed. We also need to make sure we create a renv.log file, which will contain all the information about the dependencies and the R version that we use. So to do that, we do renv snapshot. Yes, we want to proceed. And here's our renv log file. If we open it, we see that we are using version 4.1.0 for R, and we are using version 0.14.0 for renv. We don't have any other dependency installed at the moment. And if we look into the renv folder, into the library, R, and here, we see that we have only renv installed. That's the only library we are using at the moment. The next thing I like to do is to work into the README file. Now the README is pretty much your greeting card to whoever is looking at the repository. In fact, if we look at the back of the repository page in GitHub, what you see under here is the content of the README file rendered. So if you don't provide a README file, it's going to be very difficult for anybody to understand what the repository is about and how to use it. So at the very least, we want to define a name of our work, and then we want to define how to install our project. In our case, the aim is simply to demo RStudio setup, and how to install is going to simply be renv restore actually, and we're going to see this command later. Okay, now we can save this, and our README file is ready. The next thing I like to do is to go into the gitignore and add a couple of files there. The first file I want to add, and we can add it at this level here, is this rproj file. So let's do that, and we can add it like that. Rproj. The reason why I want to add this file to the gitignore and I don't want it in the repository is because it contains configurations that are specific to yourself rather than to the project. For instance, if we open it up, we can have a look at it. You have things like the code editing settings, stuff like spelling or the building tools. Those might be specific to you rather than to the project. So you don't want to impose your preferences to other developers. That's why you don't want to commit this file. Another file I like to add to the gitignore is the README rendered. So that will be, we can add this as HTML file and also as PDF file in case we render it as a PDF. You see that by default we have the same with the Vignette. The reason why we don't want to commit to the repository those files is because we're already committing the raw version, which is the MD file, the markdown file. We don't need to commit also the product of the file. If we need the HTML or the PDF, we can simply render it again. At this point, we're ready to start coding, and we want to save all our scripts and R files into a folder called R. So we can create that folder. There we go. And inside that folder, we can create an R file. We are gonna save it. We can call it get data. And it's going to be inside the R folder, so that's correct. Save. We can also create a function inside it called get data. So let's do with no argument for now. And the function will simply return empty cars, which is a built-in R data table. Next thing we want to do to our function is to add some documentation. This function is very simple, but we want to add documentation anyway, and we want to use the roxygen standard. So using the roxygen standard, we will add a title like that. Then we will add a description. Okay, this function doesn't take any parameters, so we can skip that, but it will have a return, so we can add that. As a title, I normally add just the function name. The description is a function to return the empty cars data frame. And return is the empty cars data frame. We're now ready to start to test our code, and for testing I like to use the testthat framework. So we need to create a tests folder like that. And inside the test folder, we want to create another subfolder called testthat. And this is where all our tests are going to be saved. So we can create a testing script, it's a simple R script, and we can test our own function. So it's testthat. The function is called getData. And we can simply check, for instance, for the number of rows that we know should be 32. So we can call our function and assign the results to a variable called res. And we can then check the number of rows in res. So we can say expect equal the number of rows of res should be 32. We can now save this file. We use the testthat naming convention, so it's going to be test hyphen get data, and we want to make sure it's in test data folder, so save. Okay, we're now ready to start testing. However, if we try to click on run test, you will see we have a problem here. We cannot find the getData function. The reason why this is happening is because RStudio is really expecting you to be working in packages rather than simple collection of scripts. The good news is that it's very easy to go from where we are right now into an R package. We already done most of the work. All we need is to simply create two extra files, one called description and one called namespace. There is an easy way to do that. We can use the useThis utility. And there is a function called create package. That's the one we want to use. So we can call it. We need to specify where we want to create it, and we can use the same directory where we are right now. And it is asking now to rewrite the R project file because we are changing what we want to do with the project. And we are okay with that, so we can say 1. And we have a new session opening up with two new files, the description file and the namespace file. We don't need to worry about the namespace file that is handled by roxygen. And the description file simply contains a few metadata about your package, and you want to go in and change it as you need. For instance, you want to change the title, or you want to specify different authors or different imports and description and so on. Now that we have this set up, it's very easy to run the test. We can click run test, and there we go, our tests are running and they are passing, so everything is good. We're almost at the end. There are just 3 more folders that I would suggest you create: the Vignette folder, the inst folder, and the www folder. So let's start from the Vignette folder. The Vignette is a long form of documentation, and in the Vignette you should explain everything about your code, how to use it, why you use a certain algorithm, and how to use all the functions, what kind of inputs and output to expect, different options, and so on. For reference, if you go to cron and open the documentation for a package, normally a PDF, what you will see is a documentation. So that's the kind of standard we are aiming for. So to create the Vignette, you will simply need to create a Vignette folder. And inside the Vignette folder, we can create a markdown. We can use an R markdown. We can call it R setup demo and leave the rest as a default. This is the default R markdown Vignette, and obviously you will need to change it according to your project. And if we then save it, we save it in the Vignette folder, that's correct, and we can simply call it Vignette for now. And there we go, that's our markdown. We can preview it by clicking it. And here it is. Again, this is just the default markdown that RStudio will give you. What about if you want to add external resources to your markdown or to your codes anyway, for instance, images? Well, the best place to store those artifacts is inside a folder that we can call www. So we can create that folder. And as an example, I'm going to put into that folder a logo image. There it is, I just pasted it from another folder in my computer. And now we can, for instance, add that logo into our markdown. We can use the standard markdown syntax. We can call it AJ logo, and the path is going to be specified relatively to where the markdown is. So it's going to be in www, and the file name is logo.jpg. Then if we render our markdown again, that's our logo at the end. Finally, the last folder is the inst folder, and that's a folder that is going to contain all the scripts and auxiliary R files that you need to start your code but not to run it. You might remember from before, we say that in the R folder we save all our R files. That's true, but those files should contain only functions. They should not be scripts. If you have scripts, they should go in the inst folders, otherwise they will mess up with the tests. So we can create our inst folder, and inside our inst folder we can store any R script file as we want. You can save these inst folder as, normally you might have functions to create mock data, so we could call this file create mock data, and there it is. And then you just need to write your own function to create mock data. As a last tip, I want to tell you how you can properly store credentials like username and passwords, and global variables like thresholds or other parameters you might need in your tool. So starting from secrets, the best way to store those is using the .renviron file. So as for example, we can create one of those by simply create a generic text file, and then we can save it in the root folder as .renviron. And yeah, that's okay. At this point we can define our variables. For instance, is user name to a database, and this will be my username, for instance. And similarly we can define password to a database, and this will be my password. At this point, all we need to do is to restart our R session, and those two variables will be available as global variables. So if we can go to the console, and we can see we can get them by using sys getenv and then the name of the variables, for instance this one, and there we go. And now you can use those variables in your code. Now make sure that this file, that the .renviron file, is not committed to the repository, because obviously it contains sensitive information. So add it to the gitignore. Remember, however, to add to the README file some description of these global variables you define in the .renviron file. You need to describe what kind of variables you define, their names, and obviously you don't want to specify the value, but you need to point a new developer in the right direction by telling them maybe the email address of a person they can contact to get those credentials. Finally, for variables that are not sensitive, like for instance you can think of thresholds maybe, or some other global variables that you might need in your code, you can use the config package to properly store them. So to use the config package, we first need to create a config.yaml file. So again, we can create a simple text file and save it again in the root folder with the name config.yaml. The way you specify variables in the config file is by first of all specifying what kind of environment you're running. And this is where the config is very powerful, because you can specify different variables for different environment, for instance, for production or for test or for development. So for example, if you are in development, you might have a threshold that has a value of 10. But if you are in, let's say, in test, then the same value, the same threshold might have a value of 15. If you are in production, then you might want to use 20 instead. You can also specify a default in case no other environment is specified, and we can say that in that case the threshold is 0. We can save. So let's have a look at how we can use this configuration now. So first of all, we need to define what kind of environment we are in, if it is development or production or test. And the way we do that is by creating a global variable called r_config_active, and that's the default for the config package. Let's say we are in development, for instance, and then we can retrieve the configuration for the threshold using config get and then the name of the variables we're interested in, so threshold. So let's try that. We define our environment and the config is 10. If we look at the config file, that's correct. That's exactly what we want for development. If we change the environment, let's say now we are in production, the threshold is now 20. You probably want to save what kind of environment you are in the .renviron file. And again, if you do that, remember to add some notes about it in the README file. And we've reached the end of our video. So today we've seen that to create successfully our project, being consistent is the key. And to be consistent, you need to have a coding convention. You need to use RStudio, and you need to save your code in GitHub. We also saw that we need to structure our code as if it was an R package. So we need to create, first of all, a gitignore and a README file. That's standard practice when you use version control. And then you need to make sure that all your R functions are in a folder called R. Then you have all your tests in a testthat folder. All your data is in the data folder. All your auxiliary scripts are in the inst folder. If you have any image that you might want to use for whatever purpose, that is going to go in the www folder. The long for documentation is the Vignette, that should go in the folder called Vignette. And finally, you want to store your secrets in a file called .renviron, and you want to use the config file, the config YAML file, to store your global configurations. And with that, that's all, and thank you for watching.